this numerical on the topic of mechanics. So if you see, what you have is a cart, and this cart is carrying some, you know, plates inside it. So this is likely to be a hotel in which you have a cart, and that's your floor. Okay, this is your floor, and there is a man, whose mass is given to be 65 kgs. So this is the mass of the man. The mass of the cart is given to be 12 kgs, and the mass of the plates which the cart is carrying is given to be 7 kgs. And this man, when he pushes the ground with 120 newtons force, this cart, and the man together, both of them start accelerating. Okay, and the force of friction, which opposes this motion, is given to be around 20 newtons. Okay, so this force of friction is 20 newtons. Now the question is, what is the net acceleration of the system? And then the question is, what is the force, which is exerted by this waiter in the hotel on the cart? So we have to find the force exerted on the cart and the utensils. These are the plates on this, whole thing. So the waiter is pushing the cart. Okay. Now, if you analyze this question and carefully, if I draw the free body diagram of the waiter, the waiter is what the waiter is doing is the waiter is actually pushing, the cart here. Okay, and supposedly the push provided by the waiter is F waiter, and the cart pushes back the waiter with some force which is F cart. Now this is equal and opposite reaction. Two bodies are in touch. So what you've done is essentially, this is a Newton's third law kind of situation where the waiter is pushing the cart and the waiter is experiencing a backward force. But if you look into this part of the waiter is also experiencing, a force which is given by the floor, because the waiter's shoe, which is a feet, is pushing the ground backwards. So the waiter experiences a force of 120 newtons in the forward direction. Okay. Now, if you look into this whole situation and you decide to create, first of all, identify a system, what you can do is probably, what you draw this cart, here, and then you show an external force, which is the force of friction. And then, of course, the cart has a mass, and the material inside the cart also has a mass. So the total material, which is the plates and the trolley, together are around 19 kg. So this whole thing, is 19 kgs. Now let's select a system which includes, the man and the trolley. And if you draw that system, like this, this is what we get as the choice of system number one. Now the choice of system is very important, because if you see this question, these two forces, which are the force of this force is being applied on the floor. Okay, so this is on the floor, and this force is an external force, given by the floor to the man. So this is an external force. So the system now is made up of the waiter and the trolley and the material inside. So broadly, if you look into this whole system, what you have is a situation that, one forward force exists, which is 120 newtons, and then there is a net frictional force, on the system, which has been given to be 20 newtons. So if you calculate this whole system made up of waiter and the trolley and the material inside the trolley, what you get as F net, on this whole external system is 120 minus 20 newtons. And the whole system put together, the combined mass of the system is the mass of the waiter plus the mass of the, the trolley and the material. And this comes out to be around 19, and this is 84, kgs, which means the acceleration of the system is equal to, this comes out to be 100, and 100 divided by 84, which is 50 upon 42 is equal to 25 by 20 meter per second square. So that's the overall acceleration of the system. All right, this is part one. And, and one of the key things you have to see is that this, F, the force which is given by the cart to the waiter, is backward, and the force which the waiter gives to the trolley is F. So these are internal to the system, right? So they're equal and opposite, and they exist as an internal action and a reaction force. So these are not included; they cancel out because these are, internal forces. You don't have to worry about internal forces. So the choice of system was taken in such a manner that this action and reaction pair which exists between the trolley, this is your trolley, the man is exerting some force on the trolley, and the trolley is giving a reaction back to the man. So these two forces with respect to the system we chose, become internal forces, equal and opposite, and therefore were not included as part of these calculations. So please ignore these forces. So choice of system, can really help you simplify the overall solution. Now, the second part of the question is, what is the net force which the trolley person, this waiter experiences? So we have to calculate the force which is being experienced by the waiter himself, okay? What type of force it is. Now, if you look into the, the nature of the problem, what you find is that the waiter, is pushing the trolley with some force. If we calculate that, what is that force? That force is equal to the force experienced by the waiter. So this whole system, which is made up of trolley and the plates, the mass of this, now I'm selecting the system to be, this system, okay? So this is the system number 2, which I'm selecting. This is system number 2. Now, on this system, the net force which is given by the waiter is this. So if you look into the acceleration of the system, which you've just calculated as 25 by 21, so mass into acceleration, we know the mass is 19, because it is made up of the trolley and the material. 19 into 25 by 21. So that's a force, which is a net force, being experienced by the trolley and, the trolley plus the utensils, maybe this material. Okay, so trolley plus material. Now, this is a net force, but remember, if you look into the system 2, which is made up of trolley and the masses inside the trolley, the net force which you are getting is to the tune of 19 into 25 by 21. But we have to find this force, right? So we know the force given by the waiter is F, and then there is a frictional force acting, on this system. So your F, net, which you have calculated, if you put the force given by the waiter, the force given by waiter minus the frictional force, is the actual net force which you've calculated. So the force given by the waiter, is equal to F net, which is the force given by the, which you've calculated with the help of the formula F m into A. M is 19. The acceleration has been calculated as 25 by 21 plus what you have to do, you have to add the frictional force, which was given to be 20 newtons. So this actually, if you, this is 19 kgs. If you calculate this, this is the net force which is given by the waiter to the trolley, and the trolley in return, gives an equal and opposite reaction to the professor. So if this is a force, experienced by the trolley from the waiter experiences equal and opposite force, right? So there is a component of the, force being experienced by the waiter. So, the choice of system, really helps you eliminate unnecessary calculations and tends to simplify the overall, the equations and simplify the mechanics problem. So just stop the video and have a look at it very carefully so that you can, understand the system 1 calculations and system 2, which is made up of your utensils and the trolley itself. I hope you like this video. It's a bit complicated problem, but the emphasis on of the problem is that if you select the systems properly, you can eliminate the internal forces and then only concentrate on external forces. Thank you very much.